Good morning. And, I did not expect to be recording and doing up a class for you all on a Wednesday morning, but a funny thing happened. After yesterday's class, when I was downloading the recording for the class on the computer, it stalled out. Why? It was a longer class. There was a lot of stuff in it, and it just overwhelmed Canvas. So it stalled out, tried to restart, it all disappeared. So for those of you who we're here to give you a backup and some support, and for those of you who didn't make it, kind of redo the class for you. Won't be as long, won't be as interactive, which will make it kind of a little easier to as a recording. So without further ado, and yes, we won't have interruption from the UPS men and dogs, and we won't have to pause for 20 minutes while you do an in-class thing. So this will be shorter by about a half hour, and we'll cover everything, and we're here for you. Anyway, what's going on in Comm 4100 is, yesterday and today, talking to everybody, not to everybody, but to several of you, you all were a little concerned. Those who expressed concerns don't have a lot of background in communication. Now, when I reviewed the statistics from my survey, a lot of you are comm majors, you do have some background, and almost everybody wants to be kind of serious about this, wants to get something out of it. But then I reviewed the first assignment, and I think everybody could use a little bit of a refresher. So what we're doing this week is I have a summary of 10 scientific stories, all environmental climate change, and you just give me a good summary lead summing up each. And I think that's a really good exercise for you guys to really work on this, because everything flows from the lead of any story, broadcast, print, um, online. If you can get that lead, you're golden. Anyway, so we'll do that. That's due this Friday. 2 more days, should be able to do it. And the press release, I moved back a week. You have another week to work on that. And really, the press release assignment, I have all the information right there and a format. So it's really like what we're doing this week. You come up with a good lead, and then you just reorganize the information that's already there and put it in the press release format, which I provided. So you should be able to do that. Anyway, here is just some of the issues that we face coming into all of this. When we're talking about science, and we will be doing that, that a lot of scientists have trouble with communicators because they want their work, they work so hard, they want their work to be exactly accurate, but they're talking to themselves. So they end up, when they try to translate that to a broader audience, the audience doesn't understand. And when we try to help translate for them, we might use different terminologies, and that makes them uncomfortable to the point of thinking that we are inaccurate. Here is a little, speaking of media, here is a graphic of what scientists think of this is who's good of covering science: Nature, Science, The Economist, The Scientist. you know, physics world, all fine and good, but they have a very highly educated technical readership. So their message doesn't get out. BBC, great job. But they not everybody watches the BBC. Then you have the next tier, Atlantic, National Geographic. Again, not as broad. The ones that do have broader appeal, Washington Post, NPR, New York Times, they have a few more problems. They make mistakes. They try to make a story. You try to put a narrative so people be interested, and that sometimes gets away from the science. And then you have way out here, Food Babe, InfoWars, very partisan. You know, Huffington Post, not strong, they're partisan a little bit on the left. Fox News did pretty well because they, even though they put it in a partisan context, they still base it on facts. Again, scientists think that we're trying so hard to get an audience, to sell papers, to get clicks, to get ratings, that we forget the science and focus on the stories behind it. Guess what? That's true. As a communications person, you want to reach a broader audience. The challenge is to balance that need to get people to be interested with scientific accuracy.
Just shift the blame in a way that simply just isn't true.
Okay, need to cue this one up from the beginning.
My Big Fat Greek Wedding 3 is the #1 reason to go to the movies.
Let's do it!
Our favorite Big Fat Greek family.
These people are my age. They shouldn't look this good.
He's back.
I gotta use your shower.
Don't miss the biggest, fattest, Greekest feel-good movie of the year.
Maximum 20 people. That's 6 weeks. Everyone suck it in. This is gonna be fun.
Hi, I'm Femi OK. Welcome to the final episode in the stream's Climate Emergency Week. We're going to start this episode by going back 30 years.
In 1988, the UN established the climate.
Watch this. This is from Al Jazeera, and obviously they're not based in this country, but in a lot of ways they do a good job and they do bring a different perspective. Look at this story about the coverage of climate change.
Change organization IPCC, where scientists from the whole world agreed with James Hansen. And world leaders listened.
Those who think we're powerless to do anything about this greenhouse effect are forgetting about the White House effect.
The evidence is there. The damage is being done. We can't just do nothing.
30 years ago, we knew all about climate change and what was going on. The people, President Bush and Prime Minister Thatcher, are conservatives. They are people who are pro-business, pro-industry. They're not raging liberals. Bush, of course, is or was a conservative Republican, but they're all about climate change. So what happened?
This is more than 30 years ago. Apparently, the world was ready to act on global warming.
So what took us so long to take the climate crisis seriously? Well, one of the big reasons is because of climate deniers, climate change deniers, misinformation and disinformation. That is our show today. I would love you to take part in it. If you're on YouTube, you can do so by jumping into the comments section. You will want to talk to our guests. They have a journalist who's been covering the climate crisis and climate change for over 30 years. We have another journalist who is an expert at debunking misinformation. She will literally be showing and telling us how she does it. Stay tuned. Now that I've hyped them up, hello, Mark. Hello, Shauna. So good to have you here on the stream. Mark, will you introduce ourselves to the stream audience?
Hi, I'm Mark Hertzgaard, everybody. I am the Executive Director of Covering Climate Now. That's a consortium of hundreds of news outlets around the world, including, I'm happy to say, Al Jazeera English. And we are dedicated to improving coverage of the climate story. And as Femi said, I've been covering climate change for 30 years now for various print and broadcast outlets, including The Nation magazine, where I'm the current environment editor.
So good to have you, Mark. Hello, Shauna. Welcome to the stream. You tell everybody who you are, what you do.
Hey, Femi. I'm a journalist focusing on mis and disinformation and trying to find out how best to combat things that go viral that simply aren't true.
I want to start, Mark and Shauna, with a comment from Alyssa Wyman. And Alyssa really takes us back to what is the problem with climate crisis and why we're not better at addressing it. Here she is.
For over 50 years, big polluters have used big tobacco's playbook to spread misinformation and exploit BIPOC communities globally in order to continue their deadly businesses, deceive people, and basically bury the truth. Industry misinformation and this PR is a massive barrier to building the political will needed to enact real and just climate solutions. These corporations basically spread this misinformation themselves or use their front group.
Yep, that's what's going on.
Mark, talk to us about the scam.
Yeah, the viewer has it exactly right. And she is saying what has subsequently been confirmed by some excellent investigative reporting that began appearing about 5 years ago now from the Los Angeles Times in particular, but also Inside Climate News and the Columbia Journalism School, that essentially can be summarized in the hashtag Exxon Knew. These investigative journalists.
And I showed you that last week. Exxon was aware, and they're saying all sorts of nice things that they are doing, but they covered up a lot. They said all sorts of nice positive things, and they ignored climate change. And if you went after them, they would say things like, oh, I guess you want your electrical rates to go up. So you're hearing climate change deniers. It is in the interest of a lot of companies not to address climate change. And the problem of a journalism person is, do you represent both sides when one side is based on science and another side is a big corporation? Do you decide to not cover or to shut down somebody who has an alternative viewpoint, especially when it's not supported by science? Another little just aside, this guy is at The Nation magazine. The Nation has a reputation, if I go back to the previous previous graphic, is known for being accurate scientifically, but also it has been criticized for being liberal. Now, somewhere along the line, being anti-climate change became a conservative thing, and being for helping the planet has become a liberal thing. But as I just showed you, when it started, conservatives believed in climate change. What changed? Misinformation. Anyway, issues. Again, accuracy versus understanding, understandability. Sometimes we will Yeah, a scientist will have a story, a study. And when you try to make it understandable, a scientist will say, no, 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 you don't have it right. You're not using the right terminology. You're putting it in a broader context. And I'll talk about that in a minute. And so they're not comfortable working with people in the media. And one of the reasons, just the facts versus narrative storytelling. You'll say, oh, look at this, look at how warming in the Arctic and how that's affecting polar bears. And then you'll start a story about global warming in the Arctic, and you'll see this starving polar bear, and it's trying to feed its babies, and there's no seals because they're way out in the middle of the ocean, and there's no place to sit and go and jump in and catch seals. And that's the story of just one polar bear family. And the story of the polar bear detracts from just the facts. And scientists are often not comfortable with that. And again, that a starving polar bear, that is it about the polar bear or is it about climate change? Are we exaggerating the effects by putting things in a more narrative context? Then science versus evidence versus fact. Science doesn't do a lot of facts. Science is about understanding and hypotheses and learning, but very seldom is everything 100% true. It's about what the evidence shows. And a lot of the audience sees stuff as black and white. That's why I have this video.
Seeing if you're pre-approved will never hurt your credit score. With Capital One pre-approval, you can safely...
We need to get something straight. Evolution by natural selection is a theory. So is climate change. But people keep saying that like it's a bad thing. I get it. I understand your frustration. We're all searching for ultimate #truth, and complex, challenging ideas don't always fit nice and neatly in our brains. But what is truth? Are there different levels of truth? Are some truths truthier than others? Well, I don't know, but I do know this. Science is the absolute best tool we have for understanding how the universe works. And theory is not a four-letter word. If we're going to trust science together, the least we can do is speak the same language. Words like fact, theory, hypothesis, and law mean something totally different to a scientist than the way they're used in everyday speech. So let's get them straight. Facts are really just observations about the world around us. And we observe things every day, like that it's bright outside when I look out the window. And we often develop explanations for those observations, like, okay, the sun is probably up. Congrats, we just developed a hypothesis. But a hypothesis isn't something you prove, it's something you test. So let's walk outside. It's bright, the sun is up, hypothesis confirmed. Way to go, we did a science.
But does that make it a fact? Makes a fact that it's bright out, but watch, that doesn't mean we always understand why it's bright.
We can come up with multiple hypotheses to explain an observation. We just eliminate the ones that are wrong. What's left over is not a theory or a law or an ultimate truth. It's just a possible explanation for something, one that can lead us to new hypotheses, which may agree or disagree with the original one. It's a never-ending story, only with...
See? Okay, it's bright, the sun is out, boom, boom. That seems to be a fact, but in science, there's always a but.
Without the big fluffy dragons.
That's so good.
When enough hypotheses have gotten the old scientific check mark, we can pile these all up and turn them into something greater, a theory. A theory is the way we know something works, based on the evidence we've collected and all the hypotheses that we've successfully put to the test. The best thing about a theory is that we can use it to make predictions, and not just about the way things are, but how they will be. You may have heard someone say something like, I have a theory about why cats purr. I think it's because they're actually tiny robots, and those are their gears. Well, that's not a theory. That's actually a hypothesis. It's something that could be tested, but don't try this at home. This cycle, taking facts and observations, thinking up possible explanations, testing those explanations, and then making predictions based upon them, that's what this whole science thing is about. Being a theory.
See, this is what folks don't understand when they read science. You look, you make a hypothesis, you test it, and then you think, aha, this is why, and then you make a prediction. You notice there is no arrow between prediction and fact. You're constantly testing what's going on. We are hesitant to talk about facts. And that's a problem in both communication and in journalism and among the public who wants hard facts. In science, facts are pretty squishy. You may find vaccinations. Science tells us that vaccinations help to retard infections. It's been proven or theorized and supported again and again and again. But does that mean if your cousin has a bad reaction that it wasn't the vaccination? Yeah, people have bad reactions. Does that mean that the nanobots are in your bloodstream? No. This is the problem between science and communication and general public understanding. The public doesn't understand science.
Isn't a bad thing. It means that idea got the gold star, the blue ribbon, a big shiny trophy that says countless experiments have shown that I am sufficient to explain all the observations that I encompass. Now, to see if you got this down, let's look at some examples. Fact, people get sick. I think we can all accept that. Hypothesis, people get sick because something gets in their body and starts doing bad things. Test each hypothesis, throw out the bad ones, and we're left with a framework that lets us.
On the other hand, I know people who have gluten allergies. So does that make that false? No. The vast, and then there's autoimmune, there's other things. Germs make us sick, but it's not everything. Welcome to science.
Understand why we get sick and make predictions. The germ theory of disease. Okay, let's try another. Evolution is a fact. We know that it happens, no doubt. But how does it happen? Evolution by natural selection is a theory. We've come up with thousands and thousands of hypotheses about it, tested them, thrown out the bad ones, and we developed a pretty darn good framework for predicting how living things change over time. So yeah, it's a theory. Stop saying it like a bad thing. Calling it a theory means it's passed the toughest tests that we can throw at it. And evolution has been tested maybe more than any other theory we know of. We should really call it the theory of the fact of evolution. What about something as fundamental as gravity? Is that a theory or is it a law? In science, a law is a detailed description, usually using math, of how something happens, like the movement of gas molecules related to temperature, or how mass and energy are always conserved. But a law doesn't tell us why something happens. Gravity, as it turns out, is a law and a theory. Newton's law of universal gravitation describes precisely how two objects will attract each other based on their masses and the distance between them, and gives us a nice formula we can use to figure it out. Textbook law. But Newton's equation doesn't describe what is happening or why. To do that, we need a theory of gravity. Fact, if I drop this, it'll fall. Law, I can mathematically describe how fast that apple and the earth will accelerate toward one another based on their masses and distance. But Why is it happening? Hypothesis. There's a force pulling on the apple, or maybe there's something about the universe and the way it's structured that makes massive things fall toward one another. Or maybe the apple is like magnetically attracted to Earth or something. Eliminate the bad ones, and we're left with a theory. And thanks to Einstein, we've got a theory of gravity called general relativity. But once scientists stumbled upon quantum mechanics, they began to realize that Einstein's relativity didn't account for what was happening, the very smallest gravitational scales in the universe. General relativity is still great at describing the universe at the scale that we interact with it. But even the theory of gravity is incomplete. Does that mean we throw it out because it can't explain everything? No. I mean, if you get a flat tire on your car, you get a new car. If you change the tire, is your car a different car all of a sudden? All of these fit together to make the scientific machine. We're constantly adding and taking away parts, but it keeps on running just fine. It just means we've got more work to do to make Einstein's theory even more right. Science is never done. It's always changing, and this bothers.
Bingo. Things are always changing. We're always learning new things about, vaccines and climate change. Does that mean theories are wrong? No, when they something is, oh, that's just a theory. Yeah, if it's a theory, that means we're pretty sure it works. Now, is a theory always true? No. But in science, nothing is always true.
There's some people. How can we trust it? How can something be strong and robust if it could be different tomorrow? The goal of science is to devise frameworks that describe how things work, to truly understand why things are the way they are right now, so that we can know how things will be in the future. And if we can learn to trust science in all of its fuzziness and incompleteness, I predict that future is going to be very bright. I like that theory.
So, different worlds between people who know science and some who don't. Okay, to get to the bottom of translating science, this week and next week, we will work on a summary lead. What goes in a lead? The lead is the first paragraph of a story, broadcast, print, PR. Gives readers the points, keeps them interested, and accomplish both as few as possible. Usually it's 2 sentences. Who, what, where, when, and the second sentence, why or how, and I include WTF, who cares? Why is this important? Here's examples. Say a story, man who was injured when he fell off a roof. Man was injured yesterday after falling off a rickety ladder which collapsed as he was painting his home. Who, the man, fell off the roof at the house yesterday. Boom. Why and how. Simple. Gunman held hostage. Failed robbery at Billy Bob's barbecue resulted in 6 being held hostage as police surrounded the building. The suspect surrendered without incident. Again, 2 sentences. Here's who, what, where, when, followed by why and how. So a good lead writes itself. We will be doing an exercise shortly. Usually, like I said, 2 summary, but there are other kinds of leads. There's the anecdotal, descriptive, there's all sorts of leads. Here's one other one from NPR. Straight news lead, this is what I want you to do this week. Mass protests in Poland, legislators with the country's ruling party abruptly reversed their positions and voted against a proposal to ban abortion. Boom, straightforward. But that's not the only way to approach it. This is what I want this week, straight news. But you can be creative. Anecdotal lead. In a dilapidated morgue in the northern Brazilian city of Natal, director Marcos Brandão walks over the blood-smeared floor to where the corpses are kept. Ooh, you can picture that, especially in radio, which is a very imaginative medium. They have to draw a picture with words. And Lulu Garcia Navarro, who now is a writer for the New York Times, did that. Scene setting on the second floor of a Bavarian palace. There is a library to showing that. First person. If you are the story, first person is fine. You notice, and I was in Afghanistan, first person story is great when it's about you. Oftentimes, you don't have to use too many I's. That's implicit. Observational lead, zinger. His last meal was worth 30,000, but it killed him. Da, 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 da. Anyway, different approaches. And avoid a quote lead saying, gosh, this sucks. Because you use a quote to back up a statement. You would say, gosh, students are upset that tuition went up. Quote, gosh, this sucks, said Susie Q student. That's where you use the quote to punctuate or support the lead already. Rhetorical question, why is climate change happening? Well, what's wrong with that? Because you're asking a question that you're going to answer anyway. So why don't you just jump in and give us the answer? The quote adds nothing to the story. Okay, here's what we did in class yesterday. People did pretty good with that. One of my favorite stories. 100,000 years ago, there was another episode of climate change. The world got colder. It's the Ice Age. It was like the third Ice Age. World got colder. People had to adapt. Those who didn't died out. The human population of the time spread all throughout Africa and perhaps Asia, 100,000 people. Climate change killed 99%, leaving maybe 1,000, maybe 2,000 people. We are the descendants of those 2,000 people. Why did they survive? Not because they were big and strong like Neanderthals, because they were smart, they were able to innovate and figure out new ways to live and to adapt. Those people are our ancestors. And that's what separated us from the Neanderthals. We were able to adapt. So we're all related to that 1,000 people. Hello, cousins. That's the story here. So, okay, summary lead. Who, I'll tell you the who, you had to look. This all came from the National Science Foundation of China, the Chinese Academy of Sciences. So that's the who. What, climate change, study, all of that. Anyway, I think I have my version I'll call up in a second. But here's what you all did. Okay. There was a detrimental bottleneck to human population that threatened humanity worldwide. We saw 93,813, that bottleneck almost wipe out all our ancestors and lasted 117,000 years. Okay. Okay, detrimental bottleneck. what does that mean? In human population, we had a die-off. Say we lost 99% of the population. Around 930,000 is 117,000 a year. Yeah, you could do math. But the bottleneck, that's not what it's about. It's about climate change, and it's a study. Okay, here's new research using scientific amounts. I love science to startle an ancient tale. Our ancestors faced population collapse, dwindling from 100,000 and that's beautiful. That's poetic. Coinciding with climate change and speciation events like we had today. What's speciation? It's change, and I didn't know. I had to look that up. And this happened along with climate change. Beautiful and poetic, just a little bit more than we need. Newly developed coalescent model. What's a coalescent model? I don't know. Detects it. Yeah, it detected. It's an older study. Population coincides with major. Again, I don't know what a speciation is. People do too much of this in science writing. Human DNA has shown us there was a time when we almost became extinct, roughly 900,000 years ago, when the world was experiencing climate change, not a climate change. But the genomic data collected in a group of present day humans shows genetic material linking us to them. Pretty good. That the world was experiencing climate change, and a recent study by the Chinese Science Foundation links us back. So that's, Kerrigan, pretty good. Whoop. Researchers have faced again that bottleneck. Even though that was in the story, do we really know what a bottleneck is? 1,200 breeding individuals. We know they were breeding. That's one of those buzzwords that can be a little creepy. 1,000 individuals. This brought humanity close to extinction, shedding new light on our origins. Yes, according to a study from the Chinese National Academy. Nearly the human race has faced similar climate change as today, and it nearly caused our extinction. Really good. Population shrunk from almost a million, 100,000 down to 1,000, and we are their descendants. So yeah, it's pretty good. Y'all pretty much in the ballpark. Let me get my version. Reset. I wrote in my version. Reset. Here's my version. Human population collapsed at the same time the world faces climate change in the Pleistocene era 100,000 years ago, according to a study released by the National Science Foundation of China. According to the DNA analysis of remains of the human population collapsed from nearly 100,000 to 1,000 people. We're all pretty much saying that the difference is I put in where the study came from. But there you go. I think you're all doing pretty good. You're in the ballpark. So for this week, the homework is sum it up. We have 10 articles. Same thing we just did. Give me a lead. 60 words or less, 2 sentences. Okay, Arctic sea ice has been accelerating. It's been slowly getting worse. Oops. Heat is making us crazy. Risk of emergency department visits for mental health. Heat is making us crazy, according to that study. Drought, okay. The droughts have been getting worse because of shifts in the soil. It's not just water in the atmosphere, our soil has changed. Climate change and extreme weather. How do we know this is real? This is a kind of a broad one. There's lots of things here. Sum it up. That's a bit of a challenge. And what caused it? Again, sum it up. Changes in the ocean currents. Warming water has made the currents slow down, so our weather is going to move differently. Storms are going to sit where they are longer because the Gulf Stream isn't moving as much. And if they're sitting where they're going to, if they're not moving as much, they're going to dump rain. And here's all the things could happen. Again, sum that one up. Warmer temperature makes disease spread faster in a forest. Bad caterpillars are eating more trees because it's warmer. And they're a little bit more active and probably a little hornier. And they're eating more. Tennessee Valley. I always try to localize one. Here's about a dozen years ago, they had a big dam burst, dumped a lot of coal ash into the Tennessee River. And the question is, gosh, what did it dump in? Well, whatever it dumped in, it wasn't mercury. You're not going to get mercury poisoning from the river. So I guess that's good news. So one good news story. Well, at least it's a local story. Anyway, so that's this week's stuff. Have fun with it. We'll get back to broadcasting scripts next week, and the press release will be due next week. So that's this week's stuff, kind of summed up and tightened up, but we're here for you. Have a great rest of the week, and I will see you soon. Don't be afraid to be in touch.